Equations with two variables. Alright, to find a solution, we're going to plug in an x value and solve for y. So notice our two letters we're using are x and y almost always when we talk about equations with two variables. Why do you think that is? Well, on a graph, we have an x and a y. So for starters, that's why we use those two letters. X represents our horizontal and y represents our vertical piece. Alright? Let's practice plugging in an x value to solve for y. Here's an example. Okay, our question is find the solution for x equals -2. And we're going to write down y equals -4x plus 1. Alright, so we're just going to plug in a -2, similar to like the check step that you're very familiar with when we solve equations. It's just like that. So I'm just going to write y equals -4, but instead of putting the x, I'm plugging in the -2. And I'm going to put it in parentheses because I know a number times a letter, a number next to a letter means multiply. And then I just simplify that. So use order of operations and just simplify. I'm going to do multiplication first and then my addition. So -4 times -2 is 8. Bring down my plus 1. And y is going to equal 9. I ran out of room there, but y would be 9. Alright, why don't you try one of those on your own? Here's example 2. Okay, example 2. Find the solution for x equals -3. And we're doing y equals 2/3 x minus 2. Alright, we got to plug in. If you want to try this on your own, go ahead and pause it. And I'm going to go ahead and work it. So we have y equals 2/3. I'm going to plug in my -3 for x minus 2. And I know that this means I'm multiplying and it's by a fraction. So remember your rules. If you have a common factor on the top and bottom, like 3 is my common factor, it will go in once. 3 will go in once. So I really have 2 times -1, which is -2, over 1 times 1, which is 1. But I don't need to put that over 1, because I know anything over 1 is itself. So I just have y equals -2 minus 2. So what's y going to be? -4. Alright, so just remember you're using PEMDAS when you do this. You're just following order of operations when you plug it back in, just like the check step when we solve equations. So that's why we did multiply and then subtract. Alright, let's move on to the next topic. Alright, so linear equations. What do you think linear equations are? They make a what? Look at the root word. Line. So it makes a straight line when it's graphed. And that's what a linear equation is. A straight line when graphed. So linear equations make straight lines. Alright. Well, how do we graph them? Just a minute ago I gave you an x value and said to solve it for y. So couldn't you just make up your own x values and solve for y? Yeah, so we're going to make a table. So we're going to make a table to graph them. Alright, very funny. Not that kind of table. Alright, so we're going to choose x values like -2, 0, and 2. And those are just suggestions, but those are spaced apart to help us see what our graph is looking like. And finally, if you have a fraction next to a variable, then you want to plug in multiples of the denominator for x. And the reason I say that is so you can have an easy answer to work with, or an integer value for your y. Alright, so that's only when you have fractions. Alright, let's go ahead and make a table of our own so we can see how all this works with linear equations, how to graph them. So your example 1 is graph y equals negative 2x plus 6. Alright, so we're going to make a table. And this is how I would like you to set up all of your tables. Always put the x on the left. And then we're going to put in whatever y equals, so that negative 2x plus 6 goes over here. And then we put our y. And then we just bring the x and y together. Why do you think we do that? Because those are the ordered pairs. That way they're ready to be graphed. Alright, now that you have your table set up, let's go ahead and choose our values I asked you to plug in. So let's try negative 2, 0. I'm going to space it apart and use 2. Make sure you have some space in between those because we need to show some work. So I'm going to plug in negative 2. I'm plugging in a negative 2 for x, so I put it in parentheses, negative 2 plus 6. And now I'm just going to use my order of operations. So negative 2 times negative 2, we multiply first, then we add. Gives us positive 4 plus 6. And what does 4 plus 6 give us? 10. So I get a 10 for my y. And I'm going to write that over on the right as an ordered pair. So that was a negative 2 for my x and a 10 for my y. So it would be negative 2 comma 10. Now that point's ready to be graphed. Next up, 0. 0 is the easiest one to plug in. So I'm going to plug in a negative 2 times, instead of putting an x, I'm going to put a 0. I'll bring down my plus 6. And anything times 0 is 0. So that's 0 plus 6. And 0 plus 6 is still going to be what? 6. So writing that as an ordered pair, it'd be 0 comma 6. And finally, let's plug in a 2 for x. So negative 2 parentheses 2 plus 6. And we're going to follow order of operations, so multiply first, then add. That'd be a negative 4. Negative 2 times 2 is negative 4. Plus 6. And my larger number is positive, so that's going to be a positive 2. So that would just be 2 comma 2. So now you have your 3 ordered pairs. All you do from there is graph those 3 ordered pairs and connect them with a line drawn right through them. Okay, let's try another one. Example 2. We'll use one with a fraction this time. Fraction? Don't be scared. It's just a fraction. Alright, you can open your eyes. Remember, I gave you a shortcut or a trick to deal with those fractions. Alright, now you look more relaxed. So here we go. Example 2. Graph y equals 2/3 x minus 4. Alright, what did I teach you to do with those fractions? If you have a fraction next to a variable, just choose multiples of the variable. So I'm going to circle that 3. I'm going to choose multiples of 3. So I'm going to make my table. And there's my table. I have my x, my 2/3 x minus 4, which is what y equals. I have my y. And then I'm just putting my x and my y together to make my ordered pairs, so x comma y. Now that you have that table, remember we're going to use multiples of 3. So I'm just going to use 3. So if I plug in a 3 for x, or I'll make it a negative 3 first, so negative 3, and then 0, and then 3. Or I could use negative 6, negative 3, and 0. I'm just choosing multiples of 3, and I always want to pick a negative value and a positive value, and 0 is always a winner because it's so easy to deal with. Alright, let's begin with that. So 2/3 and then times negative 3 minus 4. Since I'm multiplying fractions, I put it over 1, and here's why I chose multiples in my denominator. 3 will go into 3 once, 3 will go into 3 once. So it's just 2 times negative 1, so that's just negative 2 over 1. So it's just negative 2 minus 4. And negative 2 minus 4 is negative 6. Now I'm not dealing with fractions. I got rid of my fractions since I was smart about what I plugged in. Yeah, we were pretty smart to use that, weren't we? So our ordered pair is negative 3 comma negative 6. Alright, let's be smart again and choose 0, because 0 is real easy to deal with. And we have 2/3 times 0 minus 4. Anything times 0 is 0, so that would just be 0 minus 4, and 0 minus 4 is negative 4. Write that as an ordered pair, and we have 0 comma negative 4. And finally, I'm using 3. So 2/3 parentheses 3 minus 4. That's really a 3 over 1. And remember, my 3's are going to cancel because I have one on the bottom, one on the top. So 3 will go into 3 once, 3 will go into 3 once, and they cancel. Multiply across, you have 2 times 1, which is 2, and 1 times 1, which is 1, so it's just 2 over 1, or 2, minus 4, and 2 minus 4 is negative 2. As an ordered pair, x comma y, that would be 3 comma negative 2. Graph those and connect them, and you have graphed y equals 2/3 x minus 4. Alright. Alright, next we're going to graph by solving for y. And we're used to this. We've translated equations, so we know how to solve for a variable if we have more than one variable. We're just going to use inverse operations. So for example 1, if we have 3x minus 2y equals 6, and we want to solve for y, I'm just going to circle the y, and I'm going to use my inverse operations. So I use PEMDAS in reverse. So that means I add and subtract first. So I have a positive 3x, so I'm going to do a minus 3x to both sides. And my 3x's are going to cancel. Am I left with 2y or negative 2y? Yeah, don't forget about that sign in front. That's a negative 2y. And then when I write this, I'm just kind of thinking ahead. It's right either way, but I'm going to put the x term first. And my x term is negative, so that's a negative 3x. And my 6 is positive, so that's a positive 6, or plus 6. Again, it's right either way, but I would prefer if you write it in this way, because later on, that's going to be in slope-intercept form, which we'll get into later. Alright, we're not done yet. We still want to solve for y, so we have one more step. We're multiplying by negative 2, so we want to divide by negative 2. And actually, since we're dividing by negative 2, we want to divide this whole thing by negative 2. So that means each of those terms we're dividing by negative 2. So I'm just going to go ahead and do it like that. Since I know I'm dividing the whole thing by negative 2, and I forgot my negatives, there they are. So divide the whole thing by negative 2, so I did it to each term. And now let's just simplify it and we're done. So y equals, a negative divided by a negative is a positive, so that's just positive 3 over 2x. And then 6 over negative 2 is negative 3. 6 divided by negative 2 is negative 3. So that's how we solve for y. We just use inverse operations. Alright, and we have one more thing to do before we're out of time. It's graphing when you just have x equals something and then just y equals something. Alright, so vertical and horizontal. So if you ever have x equals a number, alright, so when x equals a number, it's not a function. An example of that would be like x equals 2. And when x equals 2, that means x is always 2, no matter what the y value is. So if I go right 2, I can put a point. Even if my y value was 1, my x would still be right 2. If my y value was negative 1, it would be right 2. Negative 2 would be right 2. So it's always going to be right 2. So that makes it a vertical line, which is not a function. That's the only linear graph that's not a function, by the way. And then now let's jump over to horizontal. When y equals a number, it is a function because it's going to be a horizontal graph. We'll do an example of that. So if y was -1, that means when I graph it, it's always down 1 because the y tells you up and down. So we always go down 1 no matter what the x is. So even if x was 1, it would be down 1. If x was -1, it would be down 1. So it's always going to be down 1. So I'm going to show that with a horizontal line. Alright, that sums it up for our notes. And now you know how to deal with two variables.